4.2, least squares regression. All right, so here we have our club head speed. Again, we looked at in 4.1, and so we want to look at a few things with these, okay? And so we would have those points, and we could do our scatter plots if we wanted, and look at different things there on those, okay? All right, but they want us to take and look at some other things. They said, find the linear equation that relates to the club head speed by selecting 2 points, and then graph the line on the scatter diagram, and then use this to predict the distance the golf ball will travel, okay? All right, so they decided to select these 2 points. Now, the good thing is, in the computer, they will tell you the points that they want you to have, okay? So don't think that you need to select your own. They will tell you the 2 points to select here, okay? And so we're going to do that, okay? So let's go into our calculator and let's look at how we can create this line doing these things, all right? Okay, so let's go into stat. First, we need to edit. So number 1 here, let's go clear out our columns. Now in our L1, we want our X values. So our X values here are 99 and 105. All right, and then in our L2, we need our Y values. Now you need to match up. For 99, we had 258, and for 105, we had 275. Okay. All right, so now we can go back into stat. We're going to move over to calc, and we're going to do number 4 again, our linear regression. Now we still want to keep all of this stuff the same. If you're in an 83, you just press enter, and it's going to give us some information, okay? All right, so we can see here they found the slope. That is our A value that we see over there, 2.833, okay? Now they used a point slope formula, they did some work, and they came up with this equation, okay, at the end. And so we want to pay attention to certain things here. So this here is our A value, and this is our B value that we have right over here, okay? And so you can see those pieces directly on those, okay? And so we do our rounding, it all works out the same for those. So instead of having to do all that math work that I know y'all love, we can let that calculator do those pieces for us to find that equation when they ask about those, okay? And then round appropriately based on whatever they give us. All right, and so that's what they say the slope of the line is the A value, the y-intercept is the B value up there. Okay, and so that's where they connected those 2 points, they drew the line on the scatter diagram. All right, now, what about predicting if x is 104? So that's going to be plugging into that equation that we just created. So y equals 2.833 times 104 minus the 22 point, in our case 5 with this, okay? There is some rounding. They'll account for that. They know that the calculator does different things there with those, okay? And that's okay. And so we would expect that with a head speed of 104, that we would get 272.2 yards out of that, or close to it, okay? All right, so now let's look at finding the least squares regression line, okay? And then use that to make predictions. All right, so the difference between an observed value and a predicted value is called the error or residual. So whatever we expect and then what happens, we subtract those 2 things, and that's called the residual, okay? And so for instance here, if we're looking at 103 and we use that equation that we had earlier, the observed was 274, the predicted was 269.3, so the residual is 4.7 yards, okay? All right, and so here's kind of that difference. That's the distance to the line for those pieces. You can see that there in red on those. And so it's going to be different for every single point on those, okay? All right, so the least squares regression line is the line that minimizes the sum of the squared errors, okay, for that. And so we want to look and be able to find those things. All right, now again, this is all going to be the math way of doing it. So if we went through our stats, we would find all these different pieces. But we're going to let that calculator do all the work for us. Okay. All right, so let's go back to one equation that we've done before. Let's do it real quick. We're going to plug that back into our calculator here. So let's go back into stat number 1. Let's plug those in. I'm not going to worry about clearing this time. I'll just write over it 18, 13, 9, 6, and 4. All right, with those. And so we're just going to do the same thing we've been doing. We're going to go to stat, we're going to move over to calc, we're going to go to number 4. Now again, we're going to go all the way down and calculate here so that we can see our pieces. Okay? Now they do all of this work, again, going through all here, and here is their line. Well, you'll see that within some rounding that we get the same numbers on there. Okay, so again, here is their A value, here is their B value, and that's exactly what we got as well on those. Okay, and so we're going to let that calculator work for us on those pieces. So pay attention to, are they asking for the least squares regression, which means all of it, or are they giving you certain points and you got to do those points so that you know what to put into your calculator in order to get the final answer, because they will give you 2 different answers when you're looking at those things based on the information that you give. Okay. All right, so the predicted value of y hat, I know it's kind of hard to see there, sorry about that, has 2 interpretations. One is an estimate of the mean value of the response variable for a particular value of the explanatory variable. And 2, it's an estimate of the value of the response variable for a particular value of the explanatory. So one, either the mean or just the value itself. Okay. All right, so let's go back and look at the golf data, and we'll do all of those same things. Okay. And so if we were to do that in our calculator, we would come up with this information. So we would still go to our linear regression, just like we've been doing, and they would give us this little table over here to our left to get the same thing, okay? All right, and so they see that we have a slope of 3.166 and then a y value or a y-intercept of negative 55.796. All right. And so we could draw that line. So you would select a line on those that matches that piece. Now, typically on this one, you're going to be looking for the dots to help you if you need to select a graph like that. Okay. Now, if we wanted to estimate on this one with x being 103, then we would plug that into that new equation that we just wrote there using the slope and the y-intercept. And so we would estimate that if our head speed is 103, that we should get 270 yards out of this. Okay. All right. Now the actual was 274. So that means our residual was 3.7 because we took the 274 that was actually observed minus what we expected of 270.3, and we subtract those and we get 3.7 yards. Okay. All right. Now, looking at the slope, all of those things with those. Okay, and so in slope, we know that if we go back to algebra, slope is the rise over run, or change in y over change in x. So if we have a negative slope, or negative a value, that means it's decreasing as we go. It's going downhill with those. And then if it's a positive slope, then it's going uphill for them. Okay. And so, for instance, our club head speed there, it was 3.116. And so, as a positive, so it's increasing there as we are doing that. Okay. Now, the y-intercept is kind of its starting position on the vertical axis. And so that kind of gives us some information possibly as well. And so it asks, is 0 an acceptable value? And then can those values exist there? Well, this is negative, and we're talking about distance. And so in that case, no, that would not be acceptable for this particular piece. Okay, 0 miles per hour does not make sense as well. Okay. All right, and so we would just make predictions there based on what we know, because we don't know what's going to happen over time with those things. Things don't go forever. We know that. It's impossible. So we have to make sure that we are paying attention to our predictions and what we're doing with them. Okay. All right, then finally here, compare the squared residuals. And so here we would look at the residuals of all of these pieces and square them all out on those. So this you would have to create the table. There's not kind of anything. So if they ask about these pieces, and then compare them. Okay. And so they did that for those here in these tables. And so for our least squares regression, so the example 3 piece over here, we're getting 49. So on this one, so everything is saying should be greater than that. That's the closest it's ever going to be, because it minimizes those things. So our other one is greater here at 56, because that was only 2 points that we used compared to using all our points on those. Okay. And so this is kind of the difference between those two lines. It's not that one line is just 100% better than the other, just that the blue line is going to be the best, minimize those residuals with those. Okay. All right, so those are the things that you're going to need there for 4.2.